Welcome to my video lecture. This is an Amarnath, Assistant Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology. Under the course Matrices and Calculus, we are discussing about the solution of system of equations. In this one, using the rank method. Now, present video lecture, I am going to teach non-homogeneous system, solution of non-homogeneous system using rank method. In the previous lecture, we have studied about linear system of equations. That is the first degree more than one equation. That is a linear system of equations. We have discussed very clearly. In that one, we have two models, that is non-homogeneous and homogeneous. So, non-homogeneous means Ax is equal to B method, and homogeneous means Ax is equal to 0. These two methods under the linear system of equation we are discussing. In the previous class, we have clearly discussed about what is homogeneous, what is non-homogeneous, and consistency and inconsistency of system of equations. So, the given system of equations is said to be consistent if it has at least one solution, and no solution inconsistent. That also we have discussed. And what are the solutions of non-homogeneous system of equations? The three possibilities, that is, one is unique solution case, unique solution. That is, when exists a unique solution means rank of A is equal to rank of A by B is equal to number of unknowns. And the second one, infinite number of solutions. When the system will be having infinite number of solutions, that also we have clearly discussed in the previous class. That is, rank of A is equal to rank of A by B, which is less than number of n. The rank is less than number of unknowns. And the third one, no solution. Third one, no solution if rank of A is not equal to rank of A by B. If rank of A is not equal to rank of A by B. These are the three cases, three types of solutions are existing. Now, we will do some more problems on this system. Already we have discussed one problem in the previous video lecture. Now, we go for second problem. That is, solve the system of equations by matrix method, using matrices concept. So, first of all, see that given is a homogeneous or non-homogeneous. It is very clear here. X plus y plus z is equal to 6. 2x plus 3y minus 2z is equal to 5x plus y plus 2z is equal to 13. So, clearly RHS part is not 0. So, it is showing as Ax is equal to B. So, which is called non-homogeneous system of equations. Non-homogeneous. Okay. Then, how the solution exists based on the rank of A and rank of augmented matrix A by B. Both we will find. So, first of all, to find the rank, we should convert the given system to matrix form. Right? Let us start the solution. Right? So, given system in matrix form. Given system in matrix form. What is the matrix form? Since it is a non-homogeneous, Ax is equal to B. Non-homogeneous system, always Ax is equal to B. Right? Now, where A is called coefficient matrix. Which coefficient? So, coefficients of the unknowns. First equation, x plus y plus z is equal to 6 means x coefficient 1, y coefficient 1, z coefficient 1. First equation. Second equation, x y z coefficient 2, 3, minus 2. Third equation, 5, 1, 2. X y z coefficients. This is called coefficient matrix. Whereas unknowns which we need to find, and unknowns in the equations, what are the values we are going to find? That is called variable matrix or unknown matrix, x, y, z. How many unknowns are there? That is here n is equal to 3. It is very important while deciding the factor. Next, B is equal to RHS. The right side of the equation constant 6, 2, 13. First equation 6, second equation 2, third equation 13. Okay. So, these are the coefficient matrix, unknown matrix, and constant matrix. So, the solution depends upon the rank of A and the rank of A by B, as we discussed very well. So, now A by B. At A and B matrix together. A matrix 1, 1, 2, 3, minus 2, 5, 1, 2. Attach column B matrix 6, 2, 13. So, this is called A by B matrix. Reduced to echelon form by applying only row operations. We know very well, to find the rank of the matrix, we use echelon form and a normal form, but here suitable method is echelon form. So using R1, make R2 element 0, R3 element 0. We are very familiar with the rank of a matrix using echelon form. So that is here R2 implies R2 minus 2R1. R3 implies R3 minus 5R1. So it is equivalent to, A by B is equivalent to. So first row no change, since we are using the first row 1, 1, 6. Second row R2 minus 2R1, 2 minus 2, 0. 3 minus 2, 1. Minus 2 minus 2, minus 4. R2 minus 2R1, 2 minus 12, 2 minus 12, minus 10. Right? Next R3 minus 5R1, 5 minus 5 into 1, 5 minus 5, 0. 1 minus 5, minus 4. 2 minus 5, minus 3. Next 13 minus 30. R3 minus 5R1, 13 minus 30. 13 minus 30 is minus 17. Okay. So still it is not in echelon form. So we have to make using second row at the second diagonal element below element 0. That is R3 implies R3 is minus 4. So let us make the R2 also plus 4. So plus 4R2. Right? R3 plus 4R2. So the matrix becomes, right? First row we are not doing any change, 1, 1, 1, 6. Second row we are not doing any change, 0, 1, minus 4, minus 10. Right? And third row we are changing, R3 plus 4R2 at a 0 plus 0. 0, minus 4 plus 4, 0. And minus 3, minus 16, minus 19. Right? Minus 90. Next, R3 plus 4R2. Minus 17, minus 40, minus 57. Now, clearly it is in echelon form. What is the checkpoint for the echelon form? So, number of zeros before the first non-zero entry. So, here 1 0, here 2 zeros. That zero should increase. So, that is echelon form. So, here if I separate the matrix, this is A matrix, this is B matrix. Now, we should display the what type of solution is existing. That is clearly we have discussed here. That is a rank of A. Since it is in echelon form, rank of A. It is clearly in echelon form. Right. Rank of A means number of non-zero rows. 1, 2, 3. If you consider only closing the last column, only if you consider the A matrix, the rank of A is equal to 3. Number of non-zero rows. Rank of A by B. That is how many here? Number of rank of A by B. The whole matrix, total matrix, this complete matrix, that is also number of non-zeros, 1, 2, 3, that is also 3, unknowns also 3, right? So, here, clearly rank of A is equal to, rank of A by B is equal to, R is equal to, N is equal to 3, all are equal means what type of solution is existing? That is, system will have unique solution. System will have a unique solution. Unique solution means consistent or inconsistent. At least one solution we say consistent. Okay. So suppose he is asking consistent or inconsistent. So since it has a solution, we say consistent. So once consistent, we can find the solution. You are telling here unique solution. Then what could be the solution? He is asking solve the equation. So we should find the unique solution. So we take the taken system Ax is equal to B. Ax is equal to A means this changed A, transformed A in the last step. So that we have 1, 1, 1. Next 0, 1, minus 4, 0, 0, minus 19 into X. X means X, Y, Z. B. B means RHS matrix. So the new B, transformed B, not the initial B. Initial B we should not take. If you take again same equation be formed, you can't solve. Here some zeros are there, easily we can solve. And some variables are reduced here, right? So 6, minus 10 and minus 57. Now using back substitution method. Back substitution method means using multiplying with the last column starting onwards. So easily directly we will get one by one variable value. Minus 19 into Z at the third row into XYZ. Multiply. Third row with XYZ. 0 into X, 0 into Y, minus 19 into Z. The minus 19Z is equal to minus 57. Compare. Right side, left side, compare on multiplying. Next, one more equation. Minus 19z is equal to 57, z is equal to 3. At 1957 by 3, z is equal to 3. So directly we can get z value. Next, take the second equation. 0 into x, 0. 1 into y, y. Minus 4 into z, minus 4z. Minus 4z. Is equal to here, second row is equal to minus 10. Substitute the z value. Y minus 4 3 is 12. Z value is 3. Is equal to minus 10. Minus 10, minus 12 transport to other side. So minus 10 plus 12, which is equal to, and the y value is 2. Next, z value. To get the z value, take the first equation. So here that is, right, here x plus y plus z is equal to 6. So x plus, so here x plus y value 2, z value 3, so is 6. So x plus 2 plus 3 is equal to 6, right? X is equal to 6 minus 5. 2 plus 3, 5, take to the side, minus 1. So 6 minus 5, 1. So finally, so you should clearly write what is the solution. Solution means the values of unknowns, x comma, y comma, z, which can satisfy all the equations. X value is 1, you should write in the proper order. X value first 1, y value 2, z value 3. So this is a solution. So whether this answer is correct or not, you can substitute in any equation, you can check. So see that one, x plus y plus z is equal to 6. So here x plus y plus z is equal to 1 plus 2 plus 3 is equal to 6. Yes, satisfying. 1 plus 2 plus 3 is equal to 6, 6 is equal to 6, satisfying. Okay, clearly not only first equation, you can substitute in second equation, you can substitute in third equation. Simultaneously, at a time, it will satisfy all the three equations, right? So we'll go for one more problem, right? Show equations x plus y plus z is equal to 6, x plus 2y plus 3z is equal to 14, x plus 4y plus 7z is equal to 30 are consistent and has at least one solution, and solve them. Let us solve this equation. So the given system in matrix form. So this is a non-homogeneous system, very clear. RHS part is there, 14, 30. So clearly it is a non-homogeneous system, right? So clearly here I am writing what is A, what is X, what is B. A is equal to coefficient of x by z in the first equation, 1, 1, 1. Second equation, 1, 2, 3. Third equation, 1, 4, 7. Okay, now first equation 1, 1, 1. Second equation 1, 2, 3. Third equation 1, 4, 7. X, Y, Z coefficient. Next, x means unknowns. X, Y, Z in this equation, in this set of system also, x, Y, Z. Sometimes P, Q, R, S or x1, x2, x3, x4, like that, they will give the different types of variables. B is equal to means RHS part. First RHS equation 6, second RHS equation 14, third equation RHS is 13. So to solve, to find consistent, in all cases we use rank of A and rank of augmented matrix A by B. So that's why here I am taking A by B, augmented matrix I am taking, which is equal to A and B together, 1, 1, 1, 1, 2, 3, 1, 4, 7, and x, y, z. So we want A and B, na? So we attach column B. Column B means 6, 14, 30. 6, 14, 30. So this is A by B. Now what we'll do, reduce to echelon form. This matrix should be changed to echelon form to find the rank, because the solution of the system of equation depends on the rank of A and rank of A by B. So using R1, make R2 element 0, R3 element 0. That is very easy. R2 implies R2 minus R1. R3 implies R3 minus R1. So this is equivalent to A by B is equivalent to, first two we are not doing any change, 1, 1, 1, 6. Second row, R2 minus R1, 1 minus 1, 0, 2 minus 1, 1, 3 minus 1, 2, 14 minus 6, that is 8. R3 minus R1, subtract the corresponding elements, that is 1 minus 1, 0, 4 minus 1, 3, 7 minus 1, 6, 30 minus 6, which is equal to 24. But still it is not in echelon form. Second diagonal element or second pivoting element, make the below element 0. That is R3 implies R3 minus 2R2. Sorry, 3R2. So because 3 minus 3 becomes 0, right? First row, no change. Second row, we are using, so no change. Third row, so third row we are doing, so that is 0 R3 minus CR2, 0 minus 0, 3 minus 3 0, 6 minus 3 into 2 6, 6 minus 6 0, 24 minus 3 into 8 24, 24 minus 24 0. Now clearly it is in echelon form. If you consider the first 3 columns, that is rank of A. If you consider, that is the rank of A by B. Now clearly it is in echelon form. So clearly it is in echelon form, right? It is in echelon form. So once it is in echelon form, you can decide the rank. So what is the rank here? So rank of A is equal to number of non-zero rows. So here since the last row is becoming 0, rank of A is equal to 2. Rank of A by B, and if you take the whole matrix, A by B matrix, complete matrix, here also 2 non-zero rows. Rank of A by B 2. In echelon form, what is the rank? Number of non-zero rows. So even you take rank of A is 2, rank of A by B also 2. But unknowns are, how many unknowns are there here? X, Y, Z. How many unknowns? 3 unknowns. X, Y, Z. Now rank of A is equal to rank of A by B, but less than number of unknowns, which we have discussed very clearly. That is infinite number of solution. R is less than n case here. So clearly here rank is 2, unknowns are 3, that is R less than n case. And the rank of A and rank of A will less than number of unknowns. In this case, system will be having infinite number of solutions. Infinite. This case is important. Infinite number of solutions. Most of the students here, they will do mistake. So infinite number of solution means one row is becoming 0, means here we are unable to find one variable value. So that can be arbitrary. How to decide one variable or two variables means we have a formula, n minus r. N means number of unknowns. Rank means 2. 3 minus 2, 1. Now what is 1? 1 indicates you have to select one variable as an arbitrary constant. This 1 indicates. That means select one variable as arbitrary constant. One variable as arbitrary constant. Constant can be any value. So K, it can take any value, arbitrary constant. Suppose I am taking one variable, generally third row is missing, you can take Z is equal to K. But there is no rule, you can take X is equal to K, Y is equal to K, Z is equal to K. So generally here last row is missing, let Z is equal to K be the arbitrary constant. Be the arbitrary constant. Arbitrary constant. Like as a previous methodology here, directly I am writing. So multiply Ax is equal to B, means A multiply with X. So that is Ax is equal to B. So A matrix. What is A matrix? The latest matrix here after transformations. In the last step, what we got? 0, 0, 0. X means unknowns. X, Y, Z. Z is K. So because already K value is fixed. Z value is fixed means Z you can give 0, 1, minus 1 to anything, which is equal to, right? RHS here 6, 8, 0. Okay. Now multiply. So like back substitution you can go. So back substitution third row 0, 0, 0. No use. Second row 0 into X 0. 1 into Y Y. Plus 2 into K 2K. Y plus 2K is equal to 8. Second row is equal to 8. First row is equal to 6. So Y is equal to 8 minus 2K. Y is equal to 8 minus 2K. Now take the first equation. Yeah, the first equation if you take 1 into the first row into this column, 1 into X, X, 1 into Y, Y, 1 into K is equal to 6. But already we have Y value. How much that Y value? X plus Y. Y value is 8 minus 2K plus K is equal to 6. Simplify this equation. X plus, so here X is equal to the constant part 6. So plus 8 take to other side. 6 minus 8. 6 minus 8 means minus 2. Minus 2K plus K. That is a minus K. If you take to the other side, plus K. K minus 2. So what is the solution here we have? Solution here. Solution is X comma Y comma Z is equal to X is K minus 2. Y is 8 minus 2K. Z is K. Right? This is a solution. So how we get infinite number of solutions? What is K? K is arbitrary constant. You can take K is equal to 0, you will get one solution. If you write K is equal to 1, another solution. Like that, how many values you give for K, you will get that many solutions. Suppose X is equal to 0, what you are getting? So that is 0 minus 2 minus 2. 8 minus 0. 8 0. One solution. Suppose if you are writing x is k 1. K is equal to 1. 1 minus 2 minus 1. 8 minus 1. 8 minus 2 into 1. 8 minus 2. That is a 6. Right? And k minus k is equal to 1. This is the one solution. Like that, how many values we can give for k? Infinite values. How many solutions we get? Infinite number of solutions. So this is a very, very important case where the students will do mistakes. So please practice this type of problems more. Right? We will go for one more problem. That is one of the important problem. The exam point of it was asked so many times. Right? Discuss for what values of lambda and mu. The simultaneous equations x plus y plus z is equal to 6, x plus 2y plus 3z is equal to 10, x plus 2y plus lambda z is equal to mu have no solution, unique solution, infinite number of solution, all possible cases is asking. So what are lambda and mu? Arbitrary constant, and it can take any value. So you need to discuss for what values of lambda and mu the given system will have no solution, unique solution, infinite number of solutions. Right? So here I am not writing A, X, B, that the students know very well. Now I will be taking the augmented matrix A by B and will solve the problem. So just like as a previous model problem only. So directly I am taking the A by B matrix. A by B matrix is coefficient matrix and RHS matrix together. First equation x plus y plus z is equal to 6 means 1, 1, 1, 6. Second equation x plus 2y plus 3z is equal to 10 at 1, 2, 3, 10. And I am writing RHS matrix also in the same thing. Right. X plus 2y plus lambda z is equal to mu. Coefficients 1, 2, lambda mu. So here this is augmented matrix. So till here if I consider first part, that is A, second part is B. So again the same methodology we will follow, reduce to echelon form. Reduce to echelon form. Okay. What is the echelon form? We know very well. So using first row we make below two elements 0. That is R2 implies R2 minus R1. R3 implies R3 minus R1. So this is equivalent to first row, no change, right? 1, 1, 6. Second row, R2 minus R1, subtract the corresponding elements. 1 minus 1, 0, 2 minus 1, 1, 3 minus 1, 2, 10 minus 6, 4. Right? Next, third row, R3 minus R1, 1 minus 1, 0, 2 minus 1, 1, lambda minus 1, and mu minus 6. But it is not in echelon form. Using second row, make below element 0. That is R3 implies R3 minus R2 is equivalent to first row 1, 1, 1, 6. Second row R3 minus, second row also no change because we are using 0, 1, 2. Which row we are using, that should not be changed. That is a basic rule. Now R3 minus R2, 0 minus 0, 0, 1 minus 1, 0, lambda minus 1 minus 2, lambda minus 3, mu minus 6 minus 4, mu minus 10. Now see, check it. So it is a clearly in echelon form. 1 zeros, 2 zeros. The number of zeros before the first non-zero entries should increase by row wise. 1 zeros, 2 zeros. Now here lambda and mu are the deciding factors. What type of solution exists? So we discussed that all clearly. So first of all, you should write it is in echelon form. So if it is in echelon form, when what could be the rank for different values of lambda and mu? So right, it is in echelon form. Now first let us discuss the first case. Right, here I am writing case 1. So let us make first these two values I will make 0. When it will become 0, lambda minus 3 will become 0, means lambda minus 3 is equal to 0, means lambda is equal to 3. Next, mu minus 10 is equal to 0, means mu is equal to 10. So first of all, I am taking, if lambda is equal to 3 and mu is equal to 10, what happens? Automatically, the last row will become 0 row. The 0, 0, 0, 0. And here 1, 1, 1, 6, the remaining values as it is, which two non-zero rows will be there. So since last row is becoming 0 row, the rank of the matrix, so first two rows non-zeros, last row lambda is equal to 3, 3 minus 3 0, 0 row, rank of A is 2. Now rank of A by B. So here mu is equal to 10, this is also becoming 0, lambda is equal to, this is also becoming 0. So definitely last row is 0 row, that is rank of A by B is equal to 2. But unknowns are 3. Here rank is less than n. Until rank of A and rank of A by B, that is equal but less than number of unknowns. That is called rank less than n. Then system has infinite number of solutions. In this case, we say the system will have infinite number of solutions. That is given in the third case, infinite number of solutions. Next, one more case we discuss, second case. What is the second case here? Another case. So, one I will make 0, another one I will not make 0. See, lambda is equal to 3. At this will become 0, this term. And mu not equal to 10. Mu not equal to means this will become non-zero. This term is becoming 0. This term is not equal to 0. This is not equal to 0. This is equal to 0. So equal to 0 means rank of A. So here these last 3 elements are 0. So 2 non-zero rows. Rank of A 2. Rank of A by B. Since mu not equal to 10. Mu not equal to 10 means 11, 12, 13, any value you can take, that will become non-zero. Non-zero means number of non-zeros will become 3. So rank of A by B is equal to 3. So clearly rank of A not equal to rank of A is 2, which is not equal to rank of A by B, which is an inconsistent case. No solution. We are very clear. Rank of A equal to rank of A by B, then only solution. That may be unique, that may be infinite. But rank of A is not equal to rank of A by B. So therefore system has no solution. And that is said to be inconsistent. Now, the case 3, one more option. So, no solution case also completed. Now, we have to get unique solution case. So, to get that one, now till now I have made lambda 0. This time, lambda minus 3 term I will not make 0. Means lambda not equal to 3. Mu can be any value. Mu can be any value. Now, once mu can be any value, right? How it is mu can be lambda not equal to 0 means it is not equal to 0. So it is not equal to 0 means the last row completely becomes non-zero row. Non-zero row means what is the rank of that one matrix? Rank of A. So since lambda minus 3 not equal to 0, that row becoming non-zero. So rank will become 3, rank of A. So rank of A by B, see, here the students will do mistake. Mu is equal to not equal to 10. No need to not equal to 10. Even 10 also no problem. Because already one element is non-zero. At the last row is a completely non-zero row. So that is 3. Unknowns are 3. All are equal. R is equal to 10. Rank of A by B, unknowns. In this case, system will be having unique solution. Right? See, clearly we have discussed for what values of the lambda and mu system can have unique solution, infinite number of solution, and these solutions. See, lambda is equal to 3, mu is equal to 10. So last row becoming 0 row. So infinite number of solution because R is less than n. Rank is 2, unknowns are 3. Lambda is equal to 3, mu not equal to 10. So rank of A is becoming 2, rank of A by B becoming 3, which are not equal to no solution. Now lambda not equal to 3, last row is becoming non-zero row. Rank of A is equal to 3, rank of A by B also 3, unknowns also 3. Then R is equal to n case. The system will have unique solution. So clearly we could able to say for what values of lambda and mu, the system will have different types of solution, all possible solutions. Right? This model problems we can expect in the examination. One of the important model. Right? So in this session, we have clearly discussed about those different types of solutions of non-homogeneous system of equations. So the and some problems. In the next class, we discuss about the homogeneous system of equation, that is Ax is equal to 0. Okay, that we will discuss. Right? Thank you.